So let us start the examples on maxima and minima. That is exercise 2.4, the second lecture. In that, the problem is find the maximum and minimum for the following function. And the function is y is equal to 5x cube plus 2x square minus 3x. As usual, let the given function, take the given function, differentiate with respect to x, find its derivative 15x square plus 4x minus 3. Okay, so for extreme values, our first condition is the first derivative must be equal to 0, equate it to the 0, then 15x square plus 4x minus 3 is equal to 0, factorize it, find the roots of this quadratic equation. You will reach to the step x is equal to minus 3 by 5 or x is equal to 1 upon 3. These are the roots, or one can say that these are the stationary points, or one can say these are the turning points of the function. Now we will differentiate the second function, second equation once again. So that is, we are obtaining the second order derivative. F dash of x is 30x plus 4. This is our equation number 3. Now we will check a sign of this second derivative at these stationary points. So for x is equal to 1 upon 3, the sign of the second derivative is positive. So f double dash at 1 by 3 is a positive value. So the given function is having minimum at x is equal to 1 upon 3 by using second derivative test. So, and the minimum value, how to obtain the minimum value? We will put x is equal to 1 upon 3 in given function to obtain the minimum value. And what is the minimum value of the function? The minimum value of the function is minus 16 upon 27. This is the minimum value. Now, similarly, at the second stationary point, minus 3 upon 5, check the sign of the second derivative at this point. It is minus 14, so less than 0. So at x is equal to minus 3 upon 5, f of x has maximum value. F of x has maximum value. So how to find the maximum value? Again, we have to put x is equal to minus 3 by 5 in this equation. So again simplify and reach to the state 36 upon 25 is the maximum value. So by second derivative test, the local minimum for f of x is minus 16 by 27 and it occurs at point x is equal to 1 upon 3. And the local maximum of f of x is 36 upon 25 at the point x is equal to minus 3 by 5. So this is the maxima and minima, that is extreme values of the function. The next example is f of x is equal to 2x cube minus 21x square plus 36 minus 20. The procedure is same throughout this. To find the extreme values, throughout we are going to find the first derivative, then roots of the first derivative, the points where the first derivative becomes 0, then they are called stationary points or turning points. Then we will find the second derivative and we will check the sign of the second derivative at those stationary points. So the first derivative and the roots are x minus 1, x minus 6. So f dash of x is equal to 0. It is necessary to have the extreme values. So f dash of x is equal to 0 implies x minus 1 into x minus 6 is equal to 0. Okay. So x is equal to 1 or x is equal to 6. These are the stationary points, or one can say turning points of the function. Now again differentiate this first derivative. So we obtain the second order derivative 12x minus 42. For x is equal to 1, from this third equation, what you get f double dash at 1 is 12 into 1 minus 42. That means minus 30, which is less than 0. So the function will have maximum value at x is equal to 1. And the maximum value will obtain by putting x is equal to 1 in the function. F of 1, 2 times 1 cube minus 21 times 1 square plus 36 times 1 minus 20. So we got the maximum value f of 1 is equal to minus 3. Now let us see at the second stationary point x is equal to 6. The sign of the second derivative at x is equal to 6 is comes out to be positive. So At x is equal to 6, the function has minimum value, and the minimum value is obtained by putting x is equal to 6 in the given function. After putting the x is equal to 6 in that equation, you obtain the value minus 128. So this is the minimum value of this function. So by using the second derivative test, the local minimum is minus 28 when x is equal to 1, and the sorry local minimum of f of x is minus 128 when x is equal to 6, and local maximum of f of x is minus 3 when x is equal to 1. Find the maximum value of the and minimum value of the function f of x is equal to x cube minus 9x square plus 24x. Take f of x, differentiate with respect to x, first obtain the x derivative, then to have the extreme values or to have the maximum and minimum values, first derivative equal to 0. So first derivative equated to 0, you get the roots x is equal to 2 or x is equal to 4. So these are the stationary points or the turning points. Now we will check the second derivative. We have to find the second order derivative. So again differentiate equation 2 with respect to x. F double dash of x is 6x minus 18. Then we will check the sign of this function at these stationary points. So at x is equal to 2, f double dash at 2 is minus 6 less than 0. So function have maximum at x is equal to 2, and the maximum value is f of 2 is equal to 2 cube minus 9 times 2 square plus 24 times 2, that is f of 2 is 20. Now at x is equal to 4, f double dash at 4 is a 6 times 4 minus 18, that means it is plus 6, so it is greater than 0. The second order derivative is positive for x is equal to 4, so the function is having minimum value at x is equal to 4, and the minimum value is f of 4 is given by 4 cube minus 9 times 4 square plus 24 times 4, and it comes out to be 16. Okay, this is the minimum value. So by second derivative test, we can say that the local minimum of f of x is 16 when x is equal to 4, and the local maximum of f of x is 20 when x is equal to 2. Find the maximum and the minimum value of the function f of x is equal to x square plus 16x. Take f of x as it is, differentiate with respect to x. The derivative of x square is 2x, and derivative of 1 upon x square is minus 2 upon x cube. So for extreme values, we must have f dash of x is equal to 0. So equate it to the 0, we get x raised to 4 is equal to 16. So we get x is equal to plus minus 2. So these are the stationary points, x is equal to 2 and x is equal to minus 2. So again differentiate this equation 2 with respect to x. So we obtain the second order derivative. F double dash of x is 2 minus 32 times minus 3 by x raised to 4. Okay. Now we will check the sign of this second derivative at these stationary points. First stationary point x is equal to 2. So f double dash at 2 is 8. So greater than 0. So function having minimum value at x is equal to 2. And the minimum value is obtained by using f of 2. It comes out to be 8. Now the second stationary point x is equal to minus 2. Put x is equal to minus 2 in f double dash. What you get? You get plus 8 again. So at x is equal to minus 2, you get the minimum value. And for minimum value, we will put x is equal to minus 2. You get f of minus 2 is equal to 8. So by second derivative test, f has minimum at x is equal to 2 and minus 2. At both the points, the function is minimum. Hence, the function has minimum value at is 8 and the points are minus 2 plus 2. Find the minimum of the following x log x. Now, logarithmic function f of x is equal to x log x. Differentiate with respect to x, use the product rule. first function as it is derivative of the second function plus second function as it is derivative of the first one. Simplify. This is our first derivative. Now for the function to have extreme values, first derivative must be equal to 0. So equate 1 plus log x is equal to 0. So log x is minus 1. But this 1 I can write it as log of e. Now this minus 1 I can take to the index log of e raised to minus 1, that is log of x is equal to log of 1 upon e. So we get x is equal to 1 upon e. Now let us find the second order derivative from equation 2. F double dash at 2, f double dash at x is equal to 1 upon x by using this second equation. So we will check the sign of this second derivative at the stationary point 1 upon e. F double dash at 1 upon e is 1 upon e is equal to e. So this is greater than 0. So the given function have minimum value at x is equal to 1 upon e. And what is the minimum value of the function? So put x is equal to 1 upon e in the given function. You get the minimum value 1 upon e log of 1 upon e. So you can take it to the numerator. I take this minus sign in front of this log by using the index property. You get minus 1 upon e log of e. But log of e is 1. So f of 1 upon e is minus 1 upon e. So by second derivative test, f has minimum value minus 1 upon e and it is at x is equal to 1 upon e. Now the next function is f of x is equal to log of x upon x, and here it is given that x is non-zero. So take the function and differentiate with respect to x. What you get? You have to use the quotient rule. Square of the denominator as it is, derivative of the numerator minus numerator as it is, derivative of the denominator. So 1 minus log x upon x square is the derivative of the given function. Now for extreme values f dash of x is equal to 0. So 1 minus log x upon x square must be equal to 0. So 1 minus log x must be equal to 0. Log of x must be equal to log of 1, that is log of e. So we get x is equal to e. Now let us find the second, this is whatever value obtained we have x, that is the stationary point or stationary value or the turning point of the function. Now differentiate this equation 2 with respect to x. Again here you have to use the quotient rule. The square of the denominator, then denominator as it is, derivative of the numerator minus numerator as it is, derivative of the denominator. So we get the derivative like this, 2 log x minus 3 upon x cube. We will check the sign of this second order derivative at this stationary point. So for x is equal to e, f double dash at e is equal to 2 times log of e minus 3 upon e raised to 3. So log of e is 1, so 2 times 1 is 1, 2 times 1 is 2, 2 in minus 3 is minus 1 upon e cube. Now e is always positive, e raised to any power you take, it is always positive. So this factor is negative, so f double dash at e is less than 0. So the function will have maximum at x is equal to e. And what is that maximum value? Maximum value of the function will be obtained by putting x is equal to e in the given function. Therefore, f of e is equal to log of e upon e. But log of e is 1, so we get 1 upon e. So the given function has maximum value 1 upon e. So by using second derivative test, f has maximum value 1 upon e, and at the point x is equal to e. Divide the number 30 in two parts such that their product is maximum. You have to divide this 30 in two parts. One can divide, one part is 10, other part is 20, one part is 25, other part is 5, one part is 29, other part is 1. Likewise, you have to divide this number 30 into two parts. So let the part of the first part be x. Now if x is the first part, obviously the other part is 30 minus x. Okay, so that their sum is 30. Now their product is maximum. So what is the product of the first and second part? Is it x into 30 minus x. So that is 30x minus x square. So this is our function which we have to maximize. So let f of x is equal to 30x minus x square. Differentiate with respect to x, we get 30 minus 2x. Now, for the extreme values or for the maximum value, the first order derivative must be equal to 0. So, if double there, so the first derivative equal to 0 implies 30 minus 2x is 0. So, x is equal to 15. This is the stationary point or the turning point. Now we have already find out the second order derivative here. So we will check the sign of the second order derivative at this point x is equal to 15. So double dash of x is already minus 2 only, so it is less than 0. So the function will have maxima at x is equal to 15. So the second order derivative f has a maximum when x is equal to 15. So the number 30 can be divided into two parts as 15, 15, so that their product is maximum. Again the same example, same type of example. Divide the number 20 into two parts such that the sum of their squares is minimum. Now here the sum of the squares is given. Let the first part be x, so other part is 20 minus x. Now what is given? Uh, the sum of their squares. So first square x square and square of the second 20 minus x is square. Their sum. This is our function which is we have to optimize or we have to maximize or minimize. So f of x is equal to x square plus 20 minus x square. Differentiating with respect to x, we get 2x minus 40 plus 2x. Okay. So the derivative is 4x minus 40. Now we can differentiate again this function with respect to x. It comes out to be 4. Now we know that for extreme values the first derivative must be equal to 0. So 4x minus 40 is equal to 0, and we get x is equal to 10. Now we will check, this is our stationary point or turning point. We will check the value of the sign of the second derivative at this stationary point. F double dash of x is equal to 4 is a constant and is greater than 0. So at x is equal to 10, the function will have minimum value. So f is minimum when x is equal to 10. So that the first part of the 20 is 10. So what will be the other part? Definitely the other part will be 10. And the function, these are the two numbers 10 and 10 whose sum is 20, and the square of them, addition of the square of them, these two numbers is minimum. Okay, so we will stop here.